Hello dear students. So in this video lecture, actually in the last video lecture we have seen about reduction and oxidation of carbonyl compounds, that means aldehyde and ketones. In this video lecture we will study two special reactions related to aldehyde and ketone. Okay, the first one is very important. It's called aldol condensation. Aldol condensation. Okay, aldol condensation. Okay, this is very important reaction. Okay, it's keep on keep coming up in the final exams, in board exams, aldol condensation. So for any aldehyde or ketone to show aldol condensation, first we have a condition. Okay, we have a condition, and the condition is that there should be one alpha hydrogen. There should be one alpha hydrogen. Now what is alpha hydrogen? So see, basically we have this double bonded carbon atom, the oxygen, carbon connected to double bonded oxygen. This is what is featured in a aldehyde or ketone. Now the adjacent carbon is called alpha carbon, and if there is a hydrogen on the alpha carbon, now this kind of molecule, whether it is aldehyde or ketone, it will show aldol condensation. Okay, now see how we will see how aldol condensation is done. So suppose the hydrogen, this is alpha hydrogen. Okay, so we will need a base. So base is required. Base will do what? It will remove this hydrogen, so we'll get this. Okay, a negative charge appearing on the carbon, and it can this can be stabilized by a resonating structure. Okay, but we will use this structure only. Okay, in the next step we will use this structure. So now this is the first molecule. Suppose this is R. Let's say this is R. Okay, so we have this structure. So let's write it again. And this one was produced in the first step. Now since this is very electronegative, it can go there. So what will happen? If this electron shifts here, we'll get a minus charge and we get a plus charge over the carbon. Now see, this carbon is negative and this carbon is positive. So these two carbons get connected. Okay, so I will write it here. So see, this is negative and this is something like that, and this carbon, it will connect from this carbon. So this carbon, it will be something like this. Okay, it will be something like this. Okay, I have connected through this carbon. Okay, let me do one thing. Let me just change the color of this carbon so that you can visualize it. Let's say that this is This is the red carbon with a negative charge. So basically this is that red carbon. Okay, this is the red carbon, and so that you can recognize to which carbon it has been attached. See, so now I hope you can you can understand that to which carbon it got attached. So this is what we got. Now in this step, what will happen? It will get a proton from water. Basically this proton will be supplied from the water, okay, because we have a we have aqueous solution of base. So what we will get, I'll just rub the first step off, okay, I'll just remove this and see from here I will write it down. So what will happen, I have R, then I have the C, not black, let's write it. C. Okay, now it's done. So on blue, on this side there is a carbon, so let's write it like this, and after red there is a carbon like this, okay, and it has 4 bonds, okay, and we have a, since proton has been transferred, so we get OH here, OH here, okay, okay, we get OH here. So see, if this is the double bonded oxygen, then this is alpha carbon and this is beta carbon, this is alpha and this is beta carbon. So this is something you may say that this is beta hydroxy aldehyde or ketone, beta hydroxy, because on beta position we have OH, okay, so this is beta hydroxy aldehyde or ketone, okay. And now from this position there will be a beta elimination, okay, there will be a beta elimination from this carbon. We have hydrogen over here, so there will be beta elimination and we'll get something like this. Okay, one will remain. Okay, and this is our final aldol product. This is our final aldol product. I will take an example. Okay, I will try to solve this problem with an example also. Okay, just to show you how the reaction goes, I have wrote all the steps. Okay, I'll take few examples and we'll see how the reaction proceeds. Okay, so we get a beta unsaturated aldehyde or ketone. Okay, so let's see, let's do an example. Suppose we have ethanol. Okay, we will take ethanol as our example. Okay, so how it will be connected? So the carbon will be, the hydrogen will be removed from the alpha carbon. So dilute NaOH. Okay, so see what will happen. This negative charge will appear and we will have something like this. Okay, so this carbon will be connected here. See, something like this will be appear. This will happen, and what we will get, we will get this. So from this carbon, okay, so we will get this negative. There is a hydrogen over here. We get CH2 and then we get this. So this is what we get after connecting these two molecules. After connecting these two molecules, this is what that we will get. And what will happen? It will get protonated, so we will get a hydrogen over here. So this is beta hydroxy. And in the final step, there will be elimination. And we'll get what? We'll get this. So what is this? We have 2 in 1 L, alpha, beta. On beta carbon we have double bond, and this is what we were looking for. This is what we call is our aldol product. Okay, this is our final aldol product. Let's do one example with ketone also. Ketone having a alpha carbon. Acetone or propanone, dilute sodium hydroxide because base is required. Now see what will happen. From this carbon, we'll get something like this. So this is our first step. Okay, this is our first step. I did this step in just a single step. Okay, but once you start practicing, I suggest you to go for the detailed stepping of this reaction initially. पहले complete steps में आप reaction को practice करो, ठीक है? एक बार आप comfortable हो जाओ, आपको ये पता चल जाएगी कौन सा कार्बन कहाँ connect होने वाला है, ठीक है? ये इतना difficult नहीं है, but start में कुछ लोग confuse हो जाते हैं कौन से कार्बन को connect करना है. Basically you have to focus on alpha carbon and the carbon to which the double bond is connected. Okay, so that these two carbons are actually important in this reaction, and from this we will have a beta elimination and we will get a product like this. So we'll get something like this. So this is 1 2 3 4 4 methyl. Then we have 1 2 3 and 5 carbons, so pent 4 into 1. Okay, so this is our final product. This is our final condensation product, and why it is called condensation? So did I do any mistake? Why 1 2 3? Oh, 1 2 3. Yeah, it appeared on the third carbon. That's true. Yeah, it should be 3. Anyways, so why is it called condensation? Because molecules are fused, are condensed to a single structure. Different aldehyde and ketones condense together to form this aldol product. Okay, so we have seen one example related to aldehyde, one example related to ketone. Then we can also have cross aldol. Okay, cross aldol condensation. It's similar to aldol condensation. It just is indifferent in a way. It's just different in a way that suppose the alkyl groups that we will use are different. Okay, so suppose in the above two examples, what we did, we took, you know, either we took ethanol or we took propanone. Okay, so suppose if I take ethanol and propanol, I combine these two. If I combine these two and I do the condensation, then what will happen? Now this is called, you know, this is what we call a cross aldol condensation. So see what will happen, we will get a mixture of product. A reaction will occur which will give us product related to condensation of ethanol. That means it will just, you know, this will react in a way that if this is not here, the only molecule is this, so one condensation product will be related to only ethanol, one product will be related to only propanol, and there will be a product from combination of these two, but there will be two products. See how two product. See, in the first step what we have seen, that base removes one hydrogen from alpha carbon. So what happens? Base removes this alpha hydrogen. Okay, now the alpha hydrogen that the base is removing, it can remove from ethanol, it can also remove the hydrogen from propanol. From both it can you know, remove the hydrogen. So if it removes hydrogen from this, we will get a different product, and if it removes the base from this, then we will get a different product. So for the first product, I'm just showing you the cross products. Okay, I'm not showing you the individual products, because if ethanol is condensed, we have already seen the reaction. If propanol is condensed, we can do this reaction. Okay, same. So what if it is crossed? So first, suppose that hydrogen is being removed from this, the base removed the hydrogen from here, so this will form the negative charge. That means what will happen? So the propanol side will give us the OH part, and this part will be connected like this. Okay, and after the elimination, what we will get? We will get so this is one of our aldol products, and it's so pen2 in 1L. So this is our product. This is our product when hydrogen is removed from ethanol. Now let's see, if the hydrogen is removed from propanol, then what we get. Okay, and I'll write it separately. I'll try to, you know, finish this reaction over here. So dilute NaOH, and now last time I removed hydrogen from here, this time I will remove hydrogen from here. So the ethanol part will be converted to this, and this will, you know, the hydrogen, you know, it will remove from here. So CH, and there will be a CHO, and CH2 will remain here. Okay, so this is what we got. And after the elimination, what we will get? We will get H will remain here, 451 is exceeded, not sure CH, so let me check. 1 2 3 4, yeah, it's a go. So this H will not be there. So this is the product, and this is what? 2-methyl but 2-in-1L. That's the name of the compound. So this is what we get if the hydrogen is removed from ethanol, and this is what we get if the hydrogen is removed from the propanol. And apart from these two products, other two products will be the condensation of ethanol itself and condensation of propanol itself. Okay, those two products will also be there. Okay, because you have mixture of these two, so this will condense individually, it will condense individually, and both of them will condense together. So ultimately we will get a mixture of 4 products. One condensation product from ethanol, one condensation product from propanol, then one condensation product related to removal of alpha hydrogen from ethanol, and one condensation product related to the removal of alpha hydrogen from propanol. Okay, so we will get 4 condensation products. Aldol condensation, I won't call it a difficult reaction, but it's a complex reaction. Actually, if we do a cross called aldol, then we get a variety of mixture products, and that's why it seems a bit complex, but it's not that difficult once you get an idea how to connect carbons and how to remove a hydrogen, and then how to connect this negative charged carbon to the same atom, to the another molecule. You will be easily be able to form that beta unsaturated aldehyde or ketone, and that is what we are looking for. That's our final condensation product. Okay, so let's move to the next topic. There is another type of a similar reaction which is called Cannizaro's reaction. I think that's double Z. It's double Z, Cannizaro. So Cannizaro reaction. And you have to keep in mind, with no alpha hydrogen. So what we have seen in the last condensation reaction, we have seen that the prime condition was that there should be alpha hydrogen, and for aldol condensation we need alpha hydrogen. Without alpha hydrogen, aldol condensation is not possible. And Cannizzaro reaction is just the reverse. Okay, see, it's just the reverse. That means this will happen only if there is no alpha hydrogen. That if alpha hydrogen is missing, then we will have Cannizzaro reaction, and if alpha hydrogen is present, then we will have Cannizzaro reaction, and we will see that the reagent is similar, and it's very easy. See, if you have CHO, and it's something like, I assume that this R contains no alpha hydrogen. Keep in mind, okay? Keep in mind that it contains no alpha hydrogen. Okay, so concentrated, you will need concentrated KOH. So basically what you need to do, just see, this is CHO actually. So basically what you need to do is, you will get 2 products. Just make an alcohol out of it. Add H here and add H here, extra H, 2H. Add 2H, one on carbon, one on oxygen, first thing, and second, make a acid salt. The rest thing will remain same. The rest thing will remains the same. One will be OHH, that means alcohol, and another will be OOK. Okay. So this is what basically happens in Cannizzaro reaction. Now let's see one example. Suppose we have methanol. Now see that methanol has no alpha carbon. So since it has no alpha carbon, so there is no question of being, of getting an alpha hydrogen. So it has no alpha hydrogen. We use concentrated KOH. What I said, HH. So what will happen? One H and another H. And next O. Okay. Got it? It's easy. Cannizzaro reaction is not that difficult. Okay. Now let's see one more example from NCERT book only. I think it's benzaldehyde. So if we have benzaldehyde, the benzaldehyde is something like this. There is a benzene ring, carbon, and something like that. Okay. So what we'll do? Hydrogen. So one hydrogen will make it CH2 and OH, benzoic acid. Benzyl alcohol. Now see. Now we will be needing concentrated KOH or NaOH. Suppose I take NaOH this time. Last time I took KOH. This time I am taking NaOH concentrated. Now see, this is the alpha carbon, and you can easily count the valency of carbon. This carbon has no hydrogen. That means on alpha carbon there is no hydrogen, and one more product will be there. And that will be simply COOK. Okay, COONA. Sorry, because I am taking Na. So CONA, and see CONA is something like this. ONA. Okay, and here's the benzene ring. So it's similar. So this is what Cannizzaro reaction is. Okay, this is Cannizzaro's reaction. Now we will go to the last part of our reaction in aldehyde. So actually this is the last part in aldehyde and ketone, and that is electrophilic substitution. So we know that CHO or this group is meta-directing and deactivating. So what will happen? Suppose we have an aldehyde. So actually electrophilic substitution is not that easy, okay, not convenient in aldehyde and ketone because it's deactivating group. So we have HNO3 and we have concentrated sulfuric acid. That means we are doing nitration. So it will go to the meta position. And only one product. In ortho-para-directive electrophilic substitution, we have seen that there is always a mixture of product. One is ortho, one is para, and we have seen that para isomer is always major product because of symmetry. But here we don't have to make a choice. There will be only one product, and the product is meta-directing, meta product, because aldehyde and ketones are meta-directing in nature. Now this is all that we have from aldehyde and ketones. From the next video lecture, we will start studying carboxylic acid. But before, I'll make that video, but before you get that video, you'll get some time, and in this time you must study. There's a small paragraph on uses of aldehyde ketone. So go through that just for your knowledge. Go through that. Read different uses of aldehydes and ketones. Okay, and go through these reactions carefully, especially aldol condensation and Cannizzaro reaction. Very important reaction. Okay, it keeps on coming all the time, so it's very important. Okay, go through them carefully.